Hello everyone, and welcome to our fourth video. At this point, you're probably already getting tired of listening to my voice on your computer, but that's a necessary evil. Okay, so here, hopefully you already read this example as it came before the video link in the notes. So here we have, it is known the length of a certain steel rod is normally distributed with mean 100 centimeters and standard deviation 0.45 centimeters. The manufacturer wants to accept 90% of all rods manufactured. Determine the length of rod that makes up the middle 90% of all steel rods manufactured. Okay, so to solve this problem, so first of all, what are we looking for? Are we looking for a probability or are we looking for x values? Okay, so here it says determine the length of the rod. So we are in fact looking for an x value. So this is similar to the immediately previous video to this, except now we're technically looking for two different x values because it says determine the length of the rods that make up the middle 90%. Okay, so we want the middle of something. So we're going to have to do a little bit of original thinking. And that original thinking is about the normal distribution. So here we want the middle 90%. So we're going to move down to the slide here. And we're going to use this diagram here, sorry. Okay, so here, and it doesn't give us how this happens. So it says use a calculator or table to find this. Okay, so here we have a normal distribution, and the x1, x2 values are given on the right, but we're going to talk today about how we actually get those x values. Okay, so it says the area of each tail is 0.05. Why is that? Well, let's switch to the whiteboard. We want the area of the middle to be 0.90. The area of exactly the middle. Okay, but the property that we know about the normal distribution is the normal distribution is symmetric. Okay, so if it's symmetric, then we can look at the middle and cut off the tails on the side. So as you see in the PowerPoint here, we can cut off because we know that this is exactly the middle because of the symmetry of the normal distribution. Now, if that's the middle, then if we have a total of 0.9 area under that center piece, that leaves only 0.1 area in total between those two tails. Okay, but there's two of them. So we divide it by 2, and we get there's exactly 0.05 area in each tail. So that's where that comes from. Okay, so we're going to start by trying to find x1. So we want the probability, we want the x value such that the probability of that x value is less than or equal to the tail on the left is equal to 0.05. Okay, so this time I'm going to use a calculator to solve this rather than go through the entire process. And we're going to find, I'm going to just write this out, so pull up the calculator. So here again, we're going to go inverse normal, distribution, inverse normal. And we want the area to be 0.05. Our mean in this situation, we have to go back and look. The mean here is 100 centimeters, standard deviation 0.45. 100 centimeters, standard deviation 0.45. And we get a x value of 99.26. Okay, does that match with what they gave us here in the PowerPoint? 99.26. Now, we could go back and we could rewrite these probabilities so that way we can get x2, or we can remember that the normal distribution is symmetric. Okay, so this is where the original thinking comes in. So we know the normal distribution is symmetric. So here, if we have our normal distribution, doesn't have to be neat here to get the point across. We have our x1 value here. We have our mean here. And we know our x2 value is going to be somewhere over here. Okay, so here, what we also know is the area in this half right here, or the tails, is the same as the area right here. We also know, because of the symmetry, because the normal distribution is symmetric, that the area, the distance on the x-axis between these two values is exactly the same as the distance on the x value between these two. So rather than even using another inverse normal, and I'm sorry the distance doesn't look equal, what we can do instead is find this distance between these two values. So what we do is we take mu minus x1. Okay. So mu is 100 minus x1, 99.26. And we get 0.74. And now we can take mu and add 2 at that and get x2. Nice and easy, just using the symmetry of the normal distribution. 100.74. Okay, and the interpretation, the length of the steel rods that make up the middle 90% of all steel rods manufactured would have lengths between 99.26 centimeters and 100.74.